So good morning, all of you. So in today's class, we are going to study the next concept is what is Newton's second law of motion and how we need to find it and all. But actually, let us comes to here. If it comes to the last previous class, we have studied what is momentum, correct? So we have a use with that here. So that is what once again we'll quickly make a quick recall regarding that momentum. So if it comes to the momentum, what is called as momentum? Good morning, Manya. What is called as momentum? Monish, Elamakel, Tamil Selvan.
Measure of quantity of motion.
Yeah, it is a measure of quantity of a motion. So which we used to represent. Understanding momentum. Momentum which we used to represent with the P. Is it yes or no? So if you take a
Yes,
momentum
sir.
of any body, momentum P is equals to, it is the product of two quantities which we used to call as what? One is mass, understanding, which we represent with the M, and another one is velocity.
Velocity.
That is what we have studied. Is it yes or no? So
Yes,
the
sir.
so the momentum which is equals to mass into velocity. So this is what we have studied. So and also I have taught you that momentum is directly proportional to mass. If you want to increase the momentum, you have to increase the mass. Or else, if you want to increase the momentum, also you can increase the velocity of your body. Is it yes or no?
Yes, sir.
What the things we have discussed in the last class, as well as mass and velocity both are inversely proportional to each other. If mass of a body is more, velocity will be less. If mass will be less, then velocity will be more. Both are
More.
inversely proportional to each other. All others also should respond. They are inversely inversely proportional to each other. So that is what will happen to each other. So now, if it comes to here, and also as we know that momentum, understanding, is present only for the objects which is in motion. Understand? So if suppose, if any object comes to rest, understand, or it is in rest, then in the state of that, is it having any momentum? Does not have any momentum. Do you understanding, all of you?
Yes, sir.
Momentum is possessed by whom? Momentum is possessed by moving objects alone. So the objects which are in rest, so what is happening? They may having mass, but velocity will become what? Velocity will become
Zero.
so anything into zero, which will give you what? Zero. Is it yes or no? So the momentum is zero. Only the objects when they are in rest. Understand? So as well as if it comes to here, momentum units, momentum P is equals to mass into velocity. So as we know, the mass unit is kilogram and velocity unit is meter per second. Is it yes or no? So the unit of the momentum is kilogram meter per second. Is it yes or no? Ra? Nobody is speaking. So
Yes,
this
sir.
is unit of momentum. Understand? Unit of momentum
Yes, sir.
is kilogram. Sorry, not gram, Ray. Here I have written meter. You are not saying why. You should say correct. Kilogram M. Where I have written M. Nobody is saying. Whatever I'll write, you will follow. So kilogram into meter per second. This is what the unit. Is it yes or no? Ra?
Yes, sir.
Yes, Pradosh, are you joined? Pradosh not yet joined. Darun joined. Darun, are you understanding, Darun? Panil Selvan? So this is what we used to call as momentum. Understand? So if you'll understand this, then we'll continue today. So today we are going to study Newton's second law of motion. All of you keep heading. Newton's second law of motion. Newton's second law of motion. You understanding, Ra? Newton's second law of motion. So this is what we will study and we'll derive the unit of Newton's second law of motion, means formula of Newton's second law of motion and etc. etc. So let's start now.
Yes, sir.
Yes. So let us come to here. All of you observe very carefully first. So what is this Newton's second law of motion means? What it will suggest means? Remember, when the two bodies when the two bodies, I have a two bodies now, understand? When heavy one and a light one, you all of you say, remember, when I'm having a two bodies, one is heavy object and another one is light one. They are acting upon by the same forces for the same time, then the light body attains a higher velocity than the heavy one. Is it true or not?
Yes, sir.
Yes or no? So now all of you observe very carefully. What is Newton's second law of motion means? What I'm saying, observe very carefully. When the two bodies, one is heavy body and another one is light body, which is acted upon by the same force for the same time, then what will happen? You please tell me. Suppose let us consider Manya. Can you able to hear me, Manya? Yes. So observe very carefully. I am taking it two bodies now. So let me consider body one. Monish, anybody having doubt, you ask me. Body one and this is body two. So now let me imagine this body one is car. For your better purpose or better understanding, I am saying you. This is car. Understanding, Elamukil? And
Yes, sir.
This is lorry. This is what lorry. Now, this is lighter object. This is heavy object. Is it yes or no? Heavy
Yes,
object.
sir.
Which is having, why it is heavy object? Having
More mass.
More mass. Do you understand? Now, this is object, lighter object. Lighter object, which is having
Less mass.
less mass. So now, just imagine all of you. For this car, I used to apply same amount of force. Force is constant. If I am applying force is constant. And here also the force is constant. Here also what? Force is constant. Both are same amount of force is acting under both the bodies. So suppose let us imagine this car. Understand? I'm applying on this car 10 Newton force. Understanding? On this car also, the truck also 10 Newton force. So which one I can easily move? Which one I can easily move? Car or
Car.
This one?
Car.
Car. Why?
Sir, because it has less mass.
Less mass. So that if you observe very carefully, as we have studied, momentum P is equals to, understanding, M into V. So here mass may be less. Here mass is less, but because of understanding, because of less mass, it will gain the more velocity. Is it yes or no?
Yes, sir.
Yes, that is. Same way if it comes to in this case, let us consider here. P is equals to mass into velocity. So here because mass is more, but velocity, the velocity gained by the body is less. Is it yes or no?
Yes, sir.
But if I am applying the same amount of force, suppose I am applying the same amount of force in both the bodies, is it the momentum is constant or not? P is equals to constant or not? That is what I am asking. Is it momentum is constant or not? Manya is not understanding, correct? So let us discuss more in detail. Now, for example, listen, if car, I am the person who is standing here, Now, imagine Elamukil, all of you will understand. Now car, which is coming with 100 km per hour, which is coming, how much speed? Is mass is less, and velocity is equals to 100 km per hour. Do you understanding all of you?
Yes, sir.
Or else you can take, because unit is meter per second, so that you can take meter per second. So let us imagine, I will explain it more clearly. Shall we take value also? Can you able to say what is the car mass? Let us consider, can I consider 50 kg? Can I consider
Yes, sir.
50 kg? So mass is equals to 50 kg. Let us imagine. And it is coming with 100 meter per second. How much it is?
100 meter per second.
Now, if it will come and will hit you, what is the momentum acting on me? What is the momentum acting by the body? Momentum, let me consider this is the case one, M1, and this is V1. So what is the momentum gained by the body? Can you able to say? Is equals to M1 into M2, M1 into V1. Is it yes or no?
Yes, sir.
Yes or no? So now,
Yes, sir.
Yes, sir.
equals to, tell me the value, 50 kg into 100 meter per second. So
100 meter.
tell me how much it is, which is equals to?
5,000.
Which is equals to?
5,000.
5,000 kilogram meter per second.
5,000 kilogram meter per second. Is it yes or no? So if this car will come and will hit you, how much momentum it will exert on me? 5,000. Is it yes or no?
Yes, sir.
So it will exert 5,000 kilogram meter per second. Will you accept it, Manya? So if this car will come and will hit me, so this is what understanding the force exerted, the momentum exerted by me. Is it yes or no?
Yes, sir.
Help of car. Now let us comes to the truck. Opposite side. Now another case, the truck is present. So as we know, let us consider truck mass is heavier than car. Is it yes or no? Nobody is responding. So okay. So this is what the truck. So truck mass is definitely heavier than car. Will you accept it?
Yes, sir.
Yes. Now you
Yes,
understand.
sir.
Suppose let me consider truck is coming with just understanding velocity of V2 10 meter per second. Velocity. What is the velocity of truck? 10 meter per
10
second.
meter per second.
Let us consider mass is heavy. It is mass is heavy. So mass is, let me imagine, 500 kg. 500 kg. Now the object which is having mass 50 kg, which is coming with 100 kilometer per hour, 100 meter per second, will come and will hit you. Will come and will hit you. Then the momentum exerted is 5,000 kilogram meter per second. Now in this case, you please tell me what is the momentum gained by the body? If the truck
3,000 kilogram meter per second.
which is
5,000 kilogram meter per second.
sorry, m2 into v2, m2 into v2. So in this case, if you'll observe, understanding momentum equals to case 2. This is case 2. That is why I'm taking everything 2. So which is equals to 500 kilogram into 10 meter per second. So both if you multiply, how much it will come, Ra? Please.
5,000.
Huh?
5,000.
5,000 kilogram meter per second.
Meter per second. So you may observe carefully here. Even though the mass is different, but the momentum gained by both the bodies is equal. Will you accept it? From this, can I say P1 is equals to P2?
Yes, sir.
Is equals to P2. Now, you may observe here why it is happening. Manya, do you understanding now? So even though here you see the body which is having less mass, the body which is having more mass, if same force is exerting, exerting on a body, then this body will gain the more velocity compared to the body which is having more mass. Is it yes or no?
Yes, sir.
Yes or no? But if we'll multiply the product of it, means a product of mass and velocity gained by this body. If the product of this mass and velocity gained by the body, then the momentum is equals to what? Momentum is equals to
Same.
Same. Do you understanding, Laksha, everybody? That is what we
Yes,
should
sir.
understand. First, you should understand.
Understood.
Even though the mass is different, one is heavier object and another one is lighter object, when we can observe here, when they are having the same force is acting at a time, same time, that is also important. When the same force is acting, then they can say the light body attains a higher velocity than the heavy one. The light body attains a higher velocity than
velocity.
the heavy one. But the momentum gained by the bodies, what we should give? The momentum gained by both the bodies is same. Is it yes or no?
Yes, sir.
Yes. So now let us comes to here. So when I'm acting, understanding, when I'm acting same amount of force at the same time, then I'm saying that momentum gained by the bodies is equal. Is it yes or no?
Yes, sir.
So that is what we are going to happening. So in this, observe carefully, we are discussing about two terms. One is force and another one is what?
Momentum.
Is it yes or no? So that is why. So the Newton's second law of motion, Newton's second law of motion will gives the relationship between, understanding, gives relationship between force and momentum. Do you understanding, Ra?
Yes, sir.
Yes, that is what we should call. So, but you remember, when the momentum will become equal of two different bodies, same force need to apply at the same time. Same force Same time if you'll apply, understanding, same time if you'll apply, then the momentum gained by the two bodies, even though heavier or lighter, the momentum is constant. That is what we should learn. Understanding, all of you? Write it. All of you should write. Newton's second law of motion. Newton's second law of motion. See, to explaining one definition, how much example I have taught. Do you understanding, right, everyone? That is what the importance. All of you should remember that. Darun, do you understanding, Darun?
Sir.
Yeah. So all of you write it. I think Alana also joined, correct now? Okay, Alana. So write it, all of you. First point. First point. Right. When two bodies, a heavy one, when two bodies, a heavy one and a light one, when two bodies, a heavy one and a light one, heavy body and light body, heavy body and light body. Do you understanding, Ra? Heavy body and light body, light one, are acted upon by the same force, same time. Same force, same time. The light body attains a higher velocity. Same time, the light body attains a higher velocity. Higher velocity means what? Speed. Higher velocity. But the momentum gained by the both the bodies is the same. The momentum higher velocity than the heavy object or else heavier object, but the momentum gained by both the bodies is same. Do you understanding, all of you?
Yes, sir.
Yes or no? So that is what you should remember. It's the same. All of you note it down. So those who want, you can note it down. Is the same. Is it clear?
Yes, sir.
Yes. So that is what we should call. So what is Newton's second law? Newton's second law will give the relationship between what? Right. What is Newton's second law? Ra? It will give the relationship between
Momentum and force.
Right. The link between force and momentum. The link between force and momentum is expressed by Newton's second law of motion. Newton's second law of motion. Do you understanding, all of you? Yes or no?
Yes, yes, sir.
Now, shall we discuss now, Pradosh? Are you there in meeting? So we will continue from here. So let us come to here. This is what we used to call as, we should know. And the example which I have taught, you have to remember first. So let us come to here. What is Newton's second law of motion? What it will say? So I am saying that it will give the relationship between understanding a force and the momentum understanding of your bodies. So now let us come to the rate of change of momentum of your body is directly proportional to the force applied. Will you accept it? Is it yes or no? Suppose the momentum is increasing, means in the sense of force is also increasing. If the momentum is decreasing, the force is also decreasing. Is it? Will you accept it or not?
Yes, sir.
All of you.
Yes, sir.
So that is only called as understanding. Now, according to the Newton's second law of motion, if momentum of a body is increasing, understanding the rate of change of momentum, either momentum is increasing or the momentum is decreasing, is directly proportional to the force applied, and as well as that force should be applied what? For the time taken. Is it yes or no? For the particular
Yes, sir.
so, and takes place in the direction in which the force acts, force acts. Understand? So, if suppose I am acting the force in this direction, the momentum is always acts in the same direction of force. Suppose the car will come and will hit me. Is it the momentum will act like this or it will act opposite direction? Is it will act opposite direction? Tell me, suppose the car will come and will hit me like this. So that momentum will act in this direction or in this direction, opposite to it.
Sir, in car direction.
Same direction, whatever the direction the car moves. Is it yes or no?
Yes, sir.
Yes, sir.
So now, the rate of change of momentum, whenever you are hearing a word called as rate of change of momentum means with respect to time. What is that? With respect
With the respective time.
Suppose you see, initially now, Elamukil coming and pushing me. Understand? At this time, I may having a momentum of some x. Now, Elamukil and Prados both will come and will push me in the same direction. So that the acting force is increasing or not? The amount of force
Yes,
which is
sir.
acting on me, increasing or not? Mavanesh, Tamil Selvan, Dharan. So the amount of
Yes,
force
sir.
is increasing. Then I will fall very fastly or I will fall slowly. I will fast.
Very fastly.
So if I am falling very fastly, then the momentum exerted also will increases or decreases?
Increases.
Increases. So now, initial case, I'm having some momentum. After understanding certain time, I'm having some another momentum. So this rate of change of momentum, understanding how much it is changes from previous case and the next case is purely depend on only one factor. What is that? The amount of force which I am exerting on it. Is it yes or no?
Yes, sir.
That is what we
Yes, sir.
call as Newton's second law of motion. Understanding? So write it all of you. And also one more thing you should remember. Suppose if Pradosh and Elamukil is pushing me in this direction, then the force, the momentum is also acting in which direction? I will fall into same direction. Correct or not? If they will push me like this,
Sir.
I will never fall like this direction. So that always the momentum is also in the same direction of force. Do you understanding all of you? It will be acting
Yes, sir.
same direction of force. That is what you should remember. Is it okay, Ma? Laksha?
Yes, sir.
Understanding, Alana? Please tell me, respond me, Alana. That is what? Write it, all of you. According to the Newton's second law of motion, write it. According to the Newton's second law of motion, according to the Newton's second law, according to the Newton's second law, what will come down? According to the Newton's second law, what will comes? Tell me, according to the Newton's second law of motion, what will comes? The rate of change of momentum. All of you write. The rate of change of momentum. Newton's second law of motion. Right. The rate of change of momentum. Change of momentum of a body is directly proportional to is directly proportional. Understand? Is directly proportional. Is directly proportional to the applied force proportional to the applied force. Applied force in which direction, Ra? In which direction?
Same direction.
Same direction of force. Force, comma, and takes place in the direction in which the force acts. Takes place in the direction in which the force acts. And takes place in the direction in which direction, and it takes place in the direction in which the force acts. Means same direction as force. That is why we can call momentum is a vector quantity or scalar quantity. Ra? It is direction also matters.
Vector quantity.
Momentum is a vector quantity.
Vector quantity.
Vector quantity. Because why? It is having
It
both.
has direction.
It has magnitude. Understand? It has magnitude. Magnitude means some number as well as and direction. Both. So if you have direction as well as magnitude, then we used to call it as vector quantity. Do you understanding, all of you?
Yes, sir.
Yes or no? So that is what you
Sir.
should do it fast, all of you now. Vector quantity. Note it down. So now, so can you able to write this definition as a formula? Can you able to say? They are saying that what? Applied force is equals to what? Force is directly proportional to rate of change of momentum. Is it yes or no? Somebody is saying chart something. What is that? Yes. Okay. Write it, all of you. Formula. Force is directly proportional to what? Change in momentum by time taken. Is it yes or no? Ra?
Yes, sir.
Momentum by time taken. That is only we used to call it as what? Rate of change of. Is it yes or no?
Yes, sir.
Yes, right. Force directly proportional to change in momentum. Change in momentum divided by time taken. Do you understanding, all of you? Time taken. So this is what Newton's second law will says that. So the rate of means time with respect to time. All of you should remember that. So rate of change of momentum is directly proportional to. This symbol is indicating what, Ra? This symbol is indicating directly
proportional
to the force applied on a body. So this is what you have to study. So now force applied is equals to here change in momentum divided by time taken. Now let me write in the form of formula. So force we should represent what, Ra? Force represent with what? F.
F.
No. So F is directly proportional to. Let us consider the rate of change of momentum of a body. Initial case 1. Suppose let me imagine I am the person. My car is at here now. Let me consider this is my car. Initially it is having a mass is constant. M is equals to some x and the speed is something like 10 meter per second. Now after certain time, is it M is will changing? Let me take here
No,
M
sir.
equals to M1. Understanding? And M2 is equals to also M equals to M only. Is it yes or no? Because mass is constant. Is it yes or no?
Yes, sir.
Now, after 1 minute, velocity is equals to, let me imagine, 20 meter per second. So now what is the momentum of this body? Is it constant or it is varies? Momentum, correct or not? So at T1 is equals to, momentum is equals to T1. At the time T1 is equals to, momentum is what? Mass into M into V1. Is it yes or no? Next.
Yes, sir.
T2 is equals to what? After certain time, T2 is equals to, momentum is equals to M into V2. Is it
M into V2.
Yeah, what is
Yes,
the
sir.
change in momentum? Can you able to say? What is the change in momentum here? Change in momentum is equals to MV2 minus MV1 with respect to time period. Is it yes or no?
Yes, sir.
So the time period also I will consider T2 minus T1. Will you understanding, Samya? T2 minus T1. Manya? Laksha. So that is what. So always if you consider a single body, I am not considering two bodies here. So if you consider a single body, always mass is constant. Is it yes or no? A single body is having same mass, but if your time is increasing, its velocity may increases so that the momentum may increases. Correct or not? So the
Yes, sir.
change in momentum means what will come, Ra? Change in momentum means what will come? Please tell me, all of you. Change in momentum means what will come? Final momentum minus
Initial momentum.
final momentum minus initial momentum. So what is the final momentum here? What is the final
Yeah.
momentum here?
V2.
mv2. Is it yes or no? So mv2
Yes, sir.
is the final momentum minus initial momentum is how much? mv1.
MV1.
Let us divide it by time taken is t. Is it okay, Ra? All of you?
Yes, sir.
Now, observe very carefully. F is directly proportional to understanding. M is constant in both the places. Can I keep it outside?
Yes, sir.
Outside V2 minus V1 divided by T. So now, observe very carefully. V2 is called as final velocity. Is it yes or no? V2
Yes,
is
sir.
called as final velocity. Understanding? And V1 is called as initial velocity. So now, if you'll observe final velocity minus initial velocity divided by time, which is equals to something in our first chapter. What is that? Can you able to say? F is
Acceleration.
acceleration. That is what the formula. All of you. Can you able to understand, Ray?
Yes, sir.
All of you. How many of you understand this?
I understood, sir.
Understood, sir.
Anybody, any doubt, you ask me. So that is what the thing. But here you see, sir, the acceleration, Monish may ask me, sir, acceleration means final velocity minus initial velocity divided by time. Is it yes or no, Monish? Your mind may asking this down. But here initial velocity I am considering as a what? V1. Is it yes or no?
Yes, sir.
No. So that is why I am getting V1 here. If not, those who want, like this also you can write it. Suppose see. So I am saying that or you can write this way. So now let us consider that this is my body. First body, my car. So is it mass is always constant or not? Mass is
Yes,
equal.
sir.
Let me imagine some m1 initial case 1, m is equals to m. Now initial case velocity, let me imagine u. Initial velocity u is equals to, understand, 10 meter per second. Now after certain time, after time t1, this time is equals to t1 is equals to, understanding something. So t. Now after certain time, t is equals to t1. Now after certain time, my car is travels to, understanding, some other speed. So still here mass is equals to m, m2 is equals to also m only. But final velocity I will consider as a v. Is it yes or no, Ra?
Yes, sir.
Initial velocity I will consider as u. Final velocity I am considering as v. Now time t2, understanding, t2 will be taken. It has been taken t2. Now what is the change in momentum? Can you able to say? So the force is applying. Force is directly proportional to change in momentum. Change in momentum. According to this case, those who are having confusion with the first thing, change in momentum divided by time taken. Is it yes or no? So now,
Yes, sir.
change in momentum, all of you should speak. Darun, force directly proportional to change in momentum means what? Final momentum. Final momentum. Understanding? Minus
Initial momentum.
initial momentum divided by, what is that? Time taken. Is it yes or no, Pradosh? No response.
Yes, sir.
All of you write. So as I can write, so force is directly proportional to, what is the final momentum, Monish? Darun, what is the final momentum here?
20
mv.
meter per second.
This is initial momentum, mu. Initial momentum is this is, and this is the final momentum. So now, what is the initial final momentum?
MV.
Minus, what is the initial momentum? mu.
MU.
Divided by time taken, t2 minus t1. So now, force, understanding, force directly proportional to m is constant, understanding, v minus u divided by t2 minus t1, which is equals to what? T. Yes or no? Divided
Yes,
by.
sir.
So now observe very carefully. V minus u divided by t. What it is looks like a.
Acceleration formula.
I can write v minus u by t, which is equals to what?
A.
equals to acceleration. Can I write it or not?
Acceleration.
Can I write it or not? So
Yes, sir.
force is directly proportional to mass into understanding acceleration. This is what, but you remember, whenever in physics, whenever in mathematics, if m is a constant, here m is a constant, is it yes or no?
Yes, sir.
Is a constant. So if we are having a constant, then we can remove this proportionality and we can keep equals to. What we can keep?
Equal to.
Equals to. So I can write force is equals to, what will come? Force is equals to constant, mass is constant, mass into acceleration. Is it yes or no?
Yes, sir.
So this is only called as, what we should call? Newton's second law of motion. F is equals to mass into
Mass into acceleration.
others also should speak. F equals to m into a. So now from this, let me say, how many of you will say, what is the relationship between force, mass and acceleration? Force is directly proportional to mass. Is it yes or no? If mass is increasing, force is increasing because both are in multiplication. Same way, force is directly proportional to acceleration. If acceleration increases, force increases. If acceleration decreases, force will decrease. Is it true or not? Will you accept it or not, all of you?
Yes, sir.
Yes, sir.
Yes. Others also should respond. So force is directly proportional to both mass and acceleration because they are the multiplication. Is it yes or no?
Yes, sir.
Yeah, somebody is having doubt.
Yes, sir.
Okay, wait. Samaya, what is Manya? What is your doubt? Please ask me. What is your doubt, Manya? Ask me. What is your doubt?
Sir, I said that the same doubt I have and that you said, sir.
Okay. No issues. So remember, whenever all of you in physics and mathematics, whenever we are removing the proportionality, we should take some constant. Understand? So here also I will take some constant. So what is that constant means? Why I am not mentioning here constant means? Let me consider the constant is k is present here. If you want to remove the proportionality, you have to take some constant. Understand? Actually here mass is also a constant for a particular body, but mass may increases or decreases. That is why we will take some constant as k, but k value is always will consider as equals to 1. Equals to how much? 1. So 1 into anything what? 1 into anything what? Same thing.
The
Is it?
same number.
So that is why k is equal, f is equals to k into mass into 1, mass into acceleration, m into a, but k is equals to 1. So that f is equals to what will become? Mass into
Acceleration.
mass into acceleration. All of you should remember that. So k is equals to 1, so that f is equals to me. So this is only called as Newton's second law of motion. What we should call?
Newton's second law of motion.
What is that? Force is
Second law
equals to mass into acceleration. Is it yes or no?
Yes, sir.
No. So f is equals to ma. So from the Newton's second